In this video, we are going to use the quadratic formula to solve some word problems. And there are many problems in life that can be modeled using quadratic equations. So for example, if a baseball player hits a pop fly, we can say that this quadratic function represents the ball's height above the ground t seconds after the ball was hit. So we want to know, well, when does the ball actually hit the ground? So the idea is, right, so if you think of this as a graph, and this is your time, and this is your height off of the ground. What you are above the ground, we'll call this above the ground. What you see is that the ball was probably hit somewhere here, let's say, depending on how high the ball was when the batter actually hit it. But the ball goes up, pop, fly, and then let's say it comes down, whoosh, back down, and it hits the ground like this. So we want to often know at what point is this ball going to hit the ground over here. Okay, so this would be some time, but when the height is above, the height is equal to 0. So what we have is 0 equals a negative 16 t squared plus 64t plus 5, and we can use our quadratic formula to solve this. So a in this case is negative 16, b in this case is 64, and c is 5. So what we're going to say is x equals, or actually in this case it's going to be t equals negative b plus or minus the square root of b squared minus 4 times a times c, and this is going to be all over 2 times a, which is negative 16. So that equals a negative 64 plus or minus the square root of, you're going to have to use your calculator to figure out some of these. This becomes 4,096. And then negative 4 times negative 16 times positive 5, okay, gives me another 320. And this is all over negative 32. So I have to figure out that 320 plus the 4,096 gives me negative 64 plus or minus the square root of 4,416 all over negative 32. Now you can take the square root of that, of this 4,416, and what you get is negative, and I would encourage you to take the square root of it for this problem since we're actually needing a decimal approximation. So I get negative 16 plus or minus, and this becomes 66.453, it looks like, all over negative 32. So what I have is I have negative 64 plus this 66 all over 32, and the negative 64 minus the 66 all over 32. That's two different answers, and they look like this. So the negative 64 plus my 66.453, and when I divide it by my negative 32, I get negative 0.077, let's say. And when I do negative 64 minus the 66.453 and then divide by the negative 32, I get, sorry, I have a habit of writing x. This is, remember again, this is t. What I get is 4.077. Now, one of these answers makes sense in this problem and one of them doesn't. You have to think about, what does t mean? Well, t means seconds after the ball was hit. So we cannot have a negative number of seconds because time doesn't work that way. So we can only use the positive answer here and make sure that when you are done, you put a unit on it, and t is in seconds. So it's approximately a little over 4 seconds after the ball was hit. That's when the ball goes up, comes back down, hits the ground. Okay? Let's take a look at one more. This is an interesting problem because we're going to need to set it up as a quadratic equation and then solve it. So it says a jazz group on tour has been drawing an average crowd of about 500 people. It is projected that for every $1 increase in the $12 ticket price, the average attendance will actually decrease by $50. So what we want to know is, at what ticket price will the nightly receipts, or the nightly amount of money that they bring in, be $5,600? Okay? So let's say X is the number of increases. Okay, so let's just look here. That when X equals 1, what happens is we take our $12 and we add a $1 times X times the number of times we increase it. This is our $1. We start with $12, we add $1 times 1 to our ticket price. But what happens to our attendance is we start with 500 and we actually decrease by 50, again times 1, because we only increased it $1. So it says that for every dollar we increase it, the average attendance will go down by 50. If we do 2 increases, we end up increasing our price by $1 times 2. But again, we are lessening our attendance 50 times 2, which would be, we'd be lessening it by 100. So what we have here is we need to figure out how the total money we bring in is going to be. And the total money is going to be the price, which is represented by this column, times the number of people, which is this column. Right? Well, we said what happens when we increased it 1 time, when we increased it 2 times. Well, we're just saying in general, we're increasing it some X number of times. And similarly, this means we're going to be decreasing the number of people who attend by 50 times some X number of increases that we make in our price. We're going to multiply the price times the number of people, and that's going to give us the total amount of nightly receipts which we are hoping to bring in, which in this case would be $5,600. Okay, so what I have here is 12 plus X, and I'm multiplying that times 500 minus 50X, and that should equal 5,600. Well, when I go ahead and multiply through and multiply this side out, I get 6,000 minus 600X, and then I have a plus 500X, and then minus 50X squared. And this equals 5,600. Now I want to combine like terms. And then I want to get everything onto one side of my equation. And I really want to rewrite it so that it's a little bit easier to understand. So I'm going to, this is 6,000. So I'm going to subtract everything over to the other side because, or add it, as this case may be. This is a little bit longer way, but I like dealing with my, the problem such that we have positive coefficients. So I get 0 equals 50x squared plus 100x minus 400. Okay? And then I can solve this using the quadratic formula. In fact, I can solve this if I first divide by 50. this actually makes this problem a little bit easier to solve. So now I have x squared plus 2x minus 8, okay? So then what happens is I solve this, right? My a equals 1, my b equals 2, my c equals negative 8. And I'm going to use my quadratic formula on this. So I say, okay, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So negative 2 plus or minus the square root of 4 plus 32 all over 2. Negative 2 plus or minus, this 4 and 32 makes 36, and the square root of 36 makes 6. So remember, I have two possible answers here. One of them is negative 2 plus 6, which gives me 4. 4 divided by 2 is 2. The other gives me negative 2 minus 6, which is negative 8. Negative 8 divided by 2 is negative 4. Remember, x is the number of increases we are going to make, the number of $1 increases. One of these answers makes sense, and one of them doesn't. You can't make a negative number of increases if you're raising the price. So you should increase by 2 times of $1, so increase by $2 to charge $14 total. Right? So it started out at 12, we're going to increase it by $2, which means we're going to be charging $14 total. And that's how we're going to use quadratic formula to set up this quadratic equation and then solve using quadratic formula. Okay, that's all we've got for this one. Keep up the good work. We'll see you in the next one.